Good day, everyone. Today we are going to discuss about limits involving functions. So the first one here is given the limit of the function 3x squared minus 4x plus 5 as x approaches to 2. In this case, we are going to find the value of the limit of 3x squared minus 4x plus 5 as x approaches to 2. So what we did here is just to simply substitute the value 2 in the x of the function. So substituting 2, it gives us 3 times the quantity of 2 to the power of 2, since it's x squared here, minus 4 times 2 plus 5. And then applying operations, we have obtained 12 minus 8 plus 5. Since 2 to the power of 2, that's 4 multiplied by 3, that is 12. Minus 8 from negative 4 times 2, and then we just copied plus 5. And applying operations, 12 minus 8 plus 5, that is 9. Meaning to say, as x approaches to 2, the values are approaching to 9. And there is no values that are greater than 9. It should only be 9.001 or 8.9, any values that approaches to 9. No values higher than that. It should be at 9, a values that has 9 on it as its whole number. Now we are here in our number 2, which gives us the limit of h squared minus 4 all over 3h to the third plus 6 as h approaches to 1. So we will just do what we did from the very first one, which is to just substitute 1 to the h of the function. Now it becomes 1 squared minus 4 all over 3 times the quantity of 1 to the power of 3 plus 6. Applying operations, 1 squared is 1 minus 4 all over 1 to the power of 3 times 3, that is 3, and then plus 6. Applying operations, it gives us negative 3 all over 9. Since 3 over 9 can be simplified, then we have simplified it and it became 1 over 9. And then, of course, not forgetting the negative sign there, and then we just copied it here, giving us the answer, negative 1 over 9. Therefore, the limit of h squared minus 4 all over 3h cubed plus 6 as h approaches to 1 is negative 1 over 9. Meaning to say again that as h approaches to 1, the values are of course approaching to negative 1 over 9. Next is the limit of z squared minus 9 all over z plus 3 as z approaches to negative 3. So since z squared minus 9 can be factored, then we have factored it by 7 minus 3 times the quantity of z plus 3. We all know that this z squared minus 9 can be factored through this way by a difference and a addition symbol all over z plus 3, since z plus 3 is already simplified. Then since we have figured out a common from them to be cancelled, which is z plus 3, then it leaves as z minus 3. So since we have already figured out z minus 3, then now we can substitute negative 3 to the z. So negative 3 minus negative 3, that is negative 6. Remembering once negative signs follows from each other, then we will just simply add them together and copy the negative sign, which is negative 6. Therefore, the limit of z squared minus 9 all over z plus 3 as z approaches to negative 3 is negative 6. So negative 6 is the limit, meaning to say the value is just until negative 6. Now we are in number 4, the limit of x as at the limit of x squared minus x negative 6 all over x squared minus 5x minus 4 rather as x approaches to negative 2. So since our fractions from both numerator and denominator can be factored, then we have factored them. So the factor of the numerator is x minus 3 times x plus 2, and then the factors of x squared minus 5x minus 14 is x plus 2 and x minus 7. Now, since we have seen a common from them to be cancelled out, then we have cancelled them, remaining x minus 3 all over x minus 7. Now, since we have simplified our function, we can now substitute negative 2 to the x of it. So it gives us negative 2 minus 3 all over negative 2 minus 7. So this is equal to negative 5 all over negative 9. Since negative over negative is positive, then our answer is in positive, giving us 5 over 9. Therefore, the limit of x squared minus x minus 6 all over x squared minus 5x minus 14 as x approaches to negative 2 is 5 over 9. Meaning to say the values are approaching 5 over 9. Next is our number 5. Given the limit of the square root of 4x squared plus 4x minus 3 all over 4x squared minus 1 as x approaches to 1 half. There is a cube root, rather, the cube root of 4x squared minus 4x minus 3 all over 4x squared minus 1, rather. Since the inner values can be factored out, then we have factored them, leaving us to plus 3 all over to x plus 1 since we have seen a common to be cancelled from it. So now since we have simplified the function, then we can substitute 1 half to the x of it. So 2 times 1 half plus 3 all over 2 times 1 half plus 1. Simplifying them all together, it leaves us the cube root of 1 plus 3 all over 2. 1 plus 3 all over 2, that's 4. Divided by 2, it gives us 2. So our answer is the cube root of 2. To say the limit of the cube root of 4x squared plus 4x minus 3 all over 4x squared minus 1 as x approaches to 1 half is the cube root of 2. Meaning to say again that as x approaches to 1 half, the values are approaching to the cube root of 2. Now we are in our number 6, which is the limit of the square root of 5y plus 4 all over y minus 5 as y approaches to negative 4. So in this case, since we cannot factor both the numerator and denominator, then we will just simply substitute negative 4 to the y of the function. So substituting the negative 4, it gives us negative 20 plus 4 all over negative 9 from here. That's so obvious. So negative 20 plus 4, that is negative 16 all over negative 9. Since negative over negative is positive, then it leaves us a positive and positive 1. So it became 16 over 9. The square root of 16 over 9. So since 16 and 9 can be, there is a square root of this both, then it leaves us the answer 4 thirds. Therefore, the limit of the square root of 5y plus 4 all over y minus 5 as y approaches to negative 4 is 4 over 3. Next, our number 7, given the limit of the square root of 9 minus t minus 3 all over t as t approaches to 0. So in this case, since we have find it to be in this way, then we will multiply it by its opposite operation. So since it is written in the square root of 9 minus t minus 3, then of course we will multiply it by its opposite, square root of 9 minus t plus 3, for us to cancel the square root symbol here. Then we will just, of course, simply copy to its denominator. Then multiplying them together, it leaves us 9 minus t minus 9 all over t times the quantity of 9 minus t plus 3. And simplifying and applying the operations, it gives us negative t all over t times the quantity of 9 minus t plus 3. And since we have simplified the function, then we will now directly substitute the 0 of this function. Substituting 0, it leaves us negative 1 all over 3 plus 3. Since 9 minus 0 is still 9, then the square root of 9, that is 3. And then adding with 3, then it gives us 6. So therefore, the limit of the square root of 9 minus t minus 3 all over t as t approaches to 0 is negative 1 over 6. Meaning to say, as t approaches to 0, or the values are approaching to 0, then the values are getting closer to negative 1 over 6. Moving forward, given the limit of 1 minus the square root of 1 plus t all over t as t approaches to 0. So same thing the from our number 7. It involves something like this. So in this case, we are going to multiply it by its opposite operation. In this case, we have just changed the operation here for this to be cancelled. The square root symbol can be cancelled. In that case, applying multiplication between them, it gives us 1 minus t all over t times the quantity of 1 plus the square root of 1 plus t. And that is equal to negative t all over t plus the quantity of 1 plus t times the quantity of 1 plus the square root of 1 plus t rather equals negative 1, since t and t can be cancelled out, and it leaves us negative. So since there is still negative there, then then it is understandable that it's negative 1. And there, the remaining values are 1 plus the square root of 1 plus 0, since we have already substituted 0 into the t. So now our answer is negative 1/2. This means that as t approaches to 0, the values are getting closer to negative 1 over 2. Moving on for our numbers 9 and 10, I am going to discuss how to prove limits using the epsilon delta definition, focusing on problems number 9 and 10 again. Recall that the formal definition of a limit states for every epsilon greater than 0, there exists a delta greater than 0, such that if 0 is less than the absolute value of x minus a and this is less than delta, then the absolute value of f of x minus L is less than epsilon. So our goal is to find a relationship between epsilon and delta. So for number 9, we are given the limit as x approaches 3 of 2x minus 5 equals 1, or the limit of 2x minus 5 as x approaches to 3 equal to 1. Let's start with f of x minus L. We compute absolute value of 2x minus 5 minus 1. Simplifying, we get 2x minus 6. This becomes 2 times the absolute value of x minus 3. And after that, we are going to relate it to the epsilon. We want 2 times the absolute value of x minus 3 less than epsilon. Divide both sides by 2. So we have delta equals epsilon over 2. And to conclude, this means whenever the absolute value of x minus 3 is less than delta, then f of x, or the absolute value of f of x minus 1, will be less than epsilon. Therefore, the limit is proven. Now for our number 10, we are given the limit as x approaches negative 2 of 8 minus 3x equals 14. So let us start again with the absolute value of f of x minus L. We compute absolute value of 8 minus 3x minus 14. Simplifying, we get absolute value of negative 3x minus 6. This becomes 3 times the absolute value of x plus 2. Related to the epsilon, we will have 3 times the absolute value of x plus 2 less than epsilon. Divide both sides by 3. we choose delta equals epsilon over 3. Then to conclude, whenever the absolute value of x plus 2 is less than delta, then the absolute value of f of x minus 14 is less than epsilon. Therefore, the limit is proven. Here again, moving on to our number 19. This is a limit of a function again. Given the limit of 2x squared minus x minus 3 all over 2x squared plus 8x plus 5 as x approaches to negative 1. So we are going to factor out 2x squared minus x minus 3 and its denominator as well. There we have found 2x minus 3 times the quantity of x plus 1 all over 3x plus 5 times the quantity of x plus 1. Since there is something that we see to be cancelled out, then we cancel x plus 1 and the x plus 1 in its denominator. So since we are now living to x minus 3 all over 3x plus 5 as its simplified form, then we are now going to substitute the negative 1 towards it. So x will be replaced by negative 1. So 2 times negative 1 minus 3 all over 3 times negative 1 plus 5. And that is negative 5 all over 2, and our answer is negative 5 all over 2. Therefore, the limit of 2x squared minus x minus 3 all over 3x squared plus 8 of x plus 5 as x approaches to negative 1 is negative 5 over 2. Meaning to say as x approaches to negative 1, the values are approaching negative 5 halves. Moving on to our number 20. Given the limit of the square root of y minus 3 all over y cubed minus 27 as y approaches to 3. So we are going to factor out its denominator since the numerator is already in its simplest form. So the factor of y to the third minus 27 is simply y minus 3 times the quantity of y squared plus 3y plus 9. Since we can cancel out y minus 3 all over y minus 3, then we are having the square root of 1 all over y squared plus 3y plus 9. Now we can substitute the 3 towards the y of it. So it gives us the answer, the square root of 1 over 27. Since the square root of 1 is 1, then it is the 27 that remains to have the symbol square root. So our answer as the limit y approaches to 3 is 1 over the square root of 27. Moving on, we have here our number 21, the limit of f of x if f of x is equal to x squared minus 1 if x is lesser than or equal to 3, and x plus 5 if 3 is lesser than x. So this involve left hand and right hand limit. So the left hand limit, we are going to consider the first function if x is lesser than or equal to 3. So of course, we are going to consider the function x squared minus 1. So it states here the limit of x squared minus 1 as x approaches 3 from the left. So we will just simply substitute 3 to the given function. 3 squared minus 1, that is equal to 9 minus 1, and 9 minus 1, that is 8. And since we are done with our left-hand limit, now we are going to move forward to our right-hand limit. Since it talks about from the right, then of course we are going to consider the second function, which is x plus 5. So here, the limit of the function x plus 5 as x approaches to 3 from the right. Then we will just simply substitute 3 to the function, to the x of the function, then 3 plus 5 is equal to 8. So since the value from the left-hand limit and our right-hand limit is the same and it is equal, then therefore the limit exists. Now moving forward to our number 22, the limit of the function or the absolute value of 3x minus 1 minus 5x as x approaches to 1/3. In this case, we will just simply substitute 1/3 to the x. So that will be 3 times the quantity of 1 over 3 minus 1, then absolute value minus 5. Then y minus 1, that is 0, minus 5, that is negative 5. Therefore, as the x approaches to 1/3, having this function as a basis, then the values approaches to negative 5. Now for our number 23, we are given the limit of 2 times the square root of x minus 6 all over x minus 9 as x approaches to 9. So in this case, since we have witnessed a cube root sign, then we are going to multiply it by its opposite operation. Since it is negative here, then we will multiply it by a positive. Then we will just copy the numerator times the numerator with having the same values and with the denominator as well. In this case, 2 times square root of x minus 6 times 2 times square root of x plus 6, that gives us 4x minus 36. And then x minus 9 times 2 times the square root of x plus 6, that gives us x minus 9 times the quantity of 2 times square root of x plus 6. Now, since 4x minus 36 rather can be factored by 4, then the remaining quantity inside is x minus 9. So since we have seen x minus 9 in its denominator, then we can cancel them together. Now, the remaining answers are 4 all over 2 times the quantity of 2 times the square root of x rather plus 16. Now, in this case, since it is simplified already, then we can substitute 9 in the x. So, substituting x, the square root of 9 is 3, multiplied by 2, that is 6, plus 6, that is 12. Then copy the numerator since there is no operation involved. Therefore, our answer is 4 over 12 or 1/3. And therefore, the limit of 2 times the square root of x minus 6 all over x minus 9 as x approaches to 9 is 1 over 3. The values are approaching to 1 over 3. Our number 24 here, we have the limit of the square root of 25 minus y squared all over 25 minus the square root of 25 minus y squared rather all over y minus 5 as y approaches to 5 from the left. So 25 minus y squared can be factored as the square root of 25 minus y times the quantity of the square root of 5 plus y all over negative 5 minus y, since y minus 5 can be written in this form for us to have something to cancel. So in this case, it happens to be square root of 5 plus y all over negative square root of 5 minus y, since we have tried to write it to be squared in its numerator. Then in that case, we have just cancelled 5 plus y, since this can be written as the square root of 5 minus y, or the squared. We have just tried to write it in the form of having an exponent, the reason why it has been simplified in this way. And then after that, substituting 5 rather, square root of 5 plus 5, that is square root of 10 all over 0. So in this case, when 0 is the denominator, then the answer must be infinity. Since there is a negative value over and then positive divided by negative, since the values are approaching from the left, then our infinity are negatives. Therefore, the limit of the function 25, the square root of 25 minus y squared, rather all over y minus 5 as y approaches 5 from the left is negative infinity. Next is number 25. The limit of 2x all over 16 minus x squared as x approaches to negative 4 from the right. So since 4 minus x and 4 plus x can be factored, then we can now substitute negative 4 in each quantities. So we don't have to furtherly express it, since we have already figured out that since it is in this form, the numerator is positive, and then the numerator here is negative and positive. So negative times positive is negative, and then with the numerator positive, then that gives us negative. So positive divided by negative, that is negative. Therefore, our answer for this is negative infinity. Or we will just simply substitute 4 there. That makes it 0, and therefore we will have the idea that our answer is infinity. It's just that since we have used this way, we have figured out that our infinity is a negative, because through getting the factor, we will know the symbol of our infinity, whether it will be negative and positive. Since we have figured out that there is negative here, the negative times positive here, that is negative, multiplied by the positive numerator, then it gives us negative. Therefore, the limit of 2x all over 16 minus x squared as x approaches to negative 4 from the right is negative infinity. Now for our number 26, the limit of the function 5 minus the square root of 4 plus 3 s all over 7 minus s as s approaches to 7. In this case, again, same thing earlier, we have found our numerator with a square root form. Therefore, we will multiply it by its opposite operation. Since it is negative here, then we will multiply it by positive here. Same, we just copied no what is here, and then what has changed is its operation, which is now positive, and same for its denominator. So 5 minus the square root of 4 plus 3s times 5 plus the square root of 4 plus 3s, that is 25 minus the quantity of 4 plus 3s, all over 7 minus s times the quantity of s plus square root of 4 plus 3s. It's from here. So the numerator can be factored. From 25 minus 4 minus 3s, it became negative 3s plus 21. Since 25 minus 4, that's 21, and then negative 3s, we just copied it. Okay, so then we just copied that denominator. So we will find a way for us to have something to cancel. So since the factor of 3s, negative 3s plus 21 is 3 times the quantity of negative s plus 7, then we can cancel it with the quantity rather from the denominator, which is negative s plus 7. Canceling them together, it leaves us 3 all over 5 plus s, since we have already substitute 7 towards it. So therefore 3, then 5 plus 5, that is equal to 10. Therefore, the limit of 5 minus the quantity of 4 plus 3s all over 7 minus s as s approaches to 7 is 3 all over 10. Next is the limit of the square root of t minus 4 all over t squared minus t, 10t plus 25 as t approaches to 5. So what will be the answer? In this case, we will just simply apply this way. So we see that we can just directly have the answer positive infinity. That's 1 over 0, since we have just applied the or substitute the values towards it. So 5 minus 4, that is 1, and then substituting 5 in this equation, that is 0. So since 0 is positive here, therefore our infinity has the symbol positive. So our answer is positive infinity. So number 32 is the limit of 4x minus 3 all over 5x squared minus x plus 1 as x approaches to negative infinity. So in this case, since we have seen that the highest exponent is from the denominator, then we will simply divide each term by x squared. So 4x divided by x squared, that is 4x, and then negative 3 becomes negative 3 over x squared. All over 5x squared divided by x squared, that is 5, and then negative x becomes negative x all over x squared, that is negative 1 over x plus 1 over x squared. So cancelling them all together, that becomes 0, and that remains as with 5. So 0 minus 0, that's 0, all over 5 minus 0 plus 0, that is 5 or 0. So our answer is 0. Number 33 is given x squared plus 5 all over 2x minus 4. In this case, we will apply again or dividing each term with x squared with the highest exponent. And since it is positive and negative here, positive divided by negative, that is negative infinity. It comes from the rule or the theorems from the limit. We are now in our number 49. We are going to get the vertical asymptote and the horizontal asymptote of the given function x plus 8 all over x minus 4. Now to get the vertical asymptote, which is of course in the vertical way, cutting half lines, we will simply extract the denominator and then make them 0. So x minus 4 equals 0. Then we will just simply move forward to the right, then it gives us the answer x equals 4. Therefore, our vertical asymptote, that is 4. Now for our horizontal asymptote, since our leading coefficients are 1, and from the rule, since they are equal, then we will just simply divide them together. So 1 over 1, that is 1. For our x-intercept and y-intercept, x plus 8 will be just all over x minus 4 will be multiplied both sides with x minus 4, leaving us x plus 8, then transforming them to 0, then x plus 8 equals 0, then then transposing it to the right, then it gives us negative 8, and then it is understandable that its y-intercept is 0. And for our y-intercept, it gives us 0 and negative 2. So now to locate them in a Cartesian plane, since our vertical asymptote is 4, then we locate 4, and then our horizontal is 1, then we locate 1. It's there. And then since of course we also locate negative 8 and 0, which are over there, and 0 negative 2, which is here. Then connecting them together, it means that our graph in this case is below here. That is in this form. And of course, for in this side, we will just simply get a value. Let's try 6. So if we put 6 plus 8, that is positive. Then 6 minus 4, that is positive. So positive divided by positive, that is positive. So our graph must be at the upper, not in the lower, since the result is positive. So it would be in this way around. This is the graph of this function. Now for our exercise number 56, Given xy minus 5x minus 3y plus 2 equals 0. So express them together, getting what is common, or simply transposing the x on the other side along with a constant. So xy minus 3y can be factored as y times the quantity of x minus 3 equals 5x minus 2. Since we can only have the y's here, so we transpose the other values. And that gives us f of x equals 5x minus 2 all over x minus 3. So for our vertical asymptote, we will just simply extract the denominator and then apply 0, x minus 3 equals 0, then transpose 3 to the left, to the right. So therefore, our vertical asymptote is x equals 3, and our horizontal asymptote, since our leading coefficient is 5, and then all over 1, so 5 divide 1, that is 5. So our horizontal asymptote is 5. Locating them here in our graph, x is 3, so we find 3 here, and then 5 as y, or the horizontal, there is 5 here. Then we locate its, let's say it's x and y intercepts, which are here. And that gives us the idea that the line is in this way, not to the upper. Now in this case, to figure out if, in this case, the line here or the graph here could be lower or the upper, then we will just apply I think it was number testing so we try 6. So 5 times 6, that's 30 minus 2, that gives us positive, and then 6 minus 3, that's positive. So positive divide positive, that's positive. Therefore, this one here should be at the upper. It shouldn't be in the lower, since it confirmed that it is in positive. So it must be at the upper. So the graph here is in this area. So this is the graph of the function 5x minus 2 all over x minus 3. We are now here in our piecewise function. F of x equals x squared minus 9 if x is lesser than 3, and 5 if x equals to 3, and 9 minus x squared if x is lesser than or equal to 3. Now, our left hand, we consider this function x squared minus 9, since it's from the left. So substituting 3, then it gives us 0. And our right hand, we have taken 9 minus x squared as the function, substituting 3 rather, it gives us 0. So they're equal here. Now in this case, since f of 3 is equal to 5 and f is not equal to 0, therefore this piecewise function has discontinuity. And here it states the limit does not equal to the function value, which is 0. So 5 is not equal to 0. Therefore, again, it has discontinuity. Now, in this case, we are going to plot it in a graph. So, it is basically obvious that the emptied one here, or the unshaded part, is in 3, 0, since it is not included. And locating x squared minus 9 and 9 minus x squared. X squared minus 9 graph is here. It goes upward, and 9 minus x squared, it goes downward. I just simply substitute each value, trying values that are that are lesser than 3. Example 2, so 2 to the power of 4, that is 4, minus 9, that is 5. So the ordered pair is 2 and negative 5. So I just locate it here to a negative 5 and then trying more values that are lesser than 3. So therefore, this is the graph of x squared minus 9. And then this is the graph of 9 minus x squared, trying all the values that are lesser than or equal to 3. And of course, here I have shaded 3 and 5, our function value, which because of that, there is discontinuity. And that will be all for this discussion. Hope you have understand about the limits, about the epsilon, about the graph, about the horizontal and vertical asymptotes, and finding the limits of a function value, of course. That will be all. Thank you and God bless.